Good morning, guys. I hope you are all well. We'll be doing physical science, Newton's laws, question 2. You have a statement there. Before attempting your questions, you have to read it, which says crate P of mass 1.25 kilograms is connected to another crate Q of mass 2 kilograms by a light and extensively string. The two crates are placed on a rough horizontal surface. A constant force of F of magnitude 7.5 newtons acting at angle theta to the horizontal is applied on crate Q as shown in the diagram below. The crates accelerate at 0.1 meters per second squared to the right, and then you're given the diagram there. As you can see, we have crate P and crate Q connected by a light and extensively string, and also a force acting oblique on crate Q. And then the following statement says crate T experiences a constant frictional force of 1.8 newtons and crate Q experiences a constant frictional force of 2.2 newtons. And then you have the first question there, which is 2.1, which says state Newton's second law of motion in words. And the Newton's second law of motion in words, we know that it says when a net force acts on an object, the object will accelerate in the direction of the net force. Acceleration is directly proportional to the net force and inversely proportional to the mass of the object. And then the following question, which is 2.2, says draw a labeled free body diagram for crate P, which now first we have to show the object there in the form of a dash, and then now you draw your direction of the forces, which you have tensional force moving to the right, because it's getting pulled by crate Q. And then you have a normal force acting perpendicular to the object, and then you have force of gravity pulling object downwards, and then also you have frictional force acting on crate P, blocking the crate P from moving forward, meaning that it's obstructing it. There's friction where it's moving. So now you get your 4 marks there, and we move to the next question, which says calculate the magnitude of the tension in the string, right? And then you tell the examiner that you'll be working at block P. Since there you have stated that Newton's second law says that when a net force acts on an object, the object will accelerate in the direction of the net force, right? Stating that doesn't mean you are not going to use the formula for that Newton's second law. Meaning that if you state a law there at the first question, the following question you have to apply that definition. So meaning that you're going to say F net is equals to MA, and then now you substitute your forces there. Forces acting on block P, you don't have to check the diagram specifically. You already drawn the free body diagram there, so you can take your forces from there. You can say T1 plus, because it's moving in the positive direction, so it has to be positive, minus Fk, it's moving on the opposite direction, so it has to be negative. It's equals to MA, and then you sub the values that you're given in the statement, which we are calculating for T1, right? And then also we're given Fk, which is like 1.8, right? And we're given mass, which is like 1.25, and we're given acceleration, which is 0.1. Just substitute, and then you find T1, which is equal to 1.25 multiplied by 0.1 plus 1.8, which is 1.925 newtons, and then you get your 4 marks. Moving to the following question, which says now we are calculating for angle theta, right? You indicate to the examiner that you'll be working at block Q, which you have oblique force acting on crate Q. So now you write the same thing, F net is equals to MA, right? And then you write your forces. In this case, you're not gonna include force F, you're just gonna include the component of force F, right? Which is F cos of theta, because it's acting horizontal. We are not focusing on a y component, we're only focusing on the x component, right? So it's moving positive because it's going to the right, plus or minus tensional force, right, which is moving opposite to the right, and then plus minus Fk, which is obstructing the object from moving forward. is equals to MA. That's all your forces acting on there. Not all per se, but the forces that are acting horizontal. There are more forces acting on the object, but we are focusing on the object causing the forces causing the object to move to the right, right? And then since you have F there, you substitute 7.5 cos of theta plus you have tension, you already calculated it, which is 1.925 plus or minus, and then frictional force is 2.2, it's equals to, and then mass is 2, and then acceleration is 0.1, and then now we can calculate for cos theta, right? Cos theta is equals to 2 multiplied by 0.1 plus 1.925 divided by 7.5. It's equal to you have 7.5 here, say 2 multiplied by 0.1 plus 2.2 plus 1.925, which gives us 4.325, and then cos theta is equals to 4.325 divided by 7.5. It's equal to 0.576666, 1 2 3 4 5 6 6, and then 7, and then theta is equals to arc of cos 0.576666, 7, and then theta is equal to arc cos 0.57666666, right? 7 is equal to theta is equals to 54.78 degrees. Thank you for your time, guys. I hope you have a wonderful day. Don't forget to like and follow.